Slow me down if I'm too fast. I would like to thank the organizers and especially my friend Miguel Torres for inviting me for this conference about the wine grapes facing climate change. I'm a specialist in wine grapes, in the genetics of wine grapes. I'm a co-author of the book called Wine Grapes, published in 2012 together with Jancis Robinson and Julia Harding. So I will focus on the possibilities regarding wine grapes and climate change. I will speak about the consequences of global warming on the varieties, the grape diversity that we can study in better conditions, and the rootstock selection. So first of all, what happens when global warming is acting on the vineyards? So this diagram comes from a very nice paper by Kimberly Nicholas in Scientific American. If you look at this diagram, is the ideal diagram. What's happening when you have ripening in the vineyard? So you have the sugar that is increasing, the acidity that is decreasing. Here you have the perfect balance between sugar and acidity. It's time for grape picking. And in an ideal world, you have the flavor potential that is at its maximum when you harvest. So this is perfect. When you have an increase in temperature and you keep the same varieties in your vineyard, what's happening? If you harvest at the same time, your berries will have shriveled. The sugar goes upwards much quicker. The acidity goes downwards much quicker. So this is the perfect ratio at this point in time. The color is not ready, and the flavor is not at its maximum. So either you harvest wines that are not ready with little flavor, or you go to ideal flavor, but you lose the balance, and you have wines that are either too acidic or too alcoholic. So this is what's happening with climate change and global warming. We have a maturity shift in the vineyard. So my question is, which Romanée Conti will we all drink in 2119? So I'm optimistic for many reasons. So I hope to be there still in 1 century from now. And also, the Romanée Conti will have changed ownership, as you can see here. I'm really optimistic. And I'm sorry, I know that Aubert de Vilaine, the current owner, is not happy with me using this fake label, but so many people do fake labels of Romanée Conti, I can make one, which is obvious that it's a fake one, it's just for fun. And especially this wine does not need any publicity, any marketing, so I'm using this label for that. So Romanée Conti, of course, is made of Pinot Noir. And Pinot has been around since 1,000 or 2,000 years, and has been multiplied by what we call vegetative propagation. It means it has been multiplied by cuttings or layerings, as you see here. So it did not have sex for 2,000 years. Can you imagine that? It did not have sex, so it did not have a genetic recombination which would allow to face the climate change by adapting itself. The only way it can adapt is by mutations, is by having different clones that could be more or less sensitive to the biotic or abiotic stresses. Because with global warming, what's happening? You have an increase in temperature, you have an increase in drought in some places, you have an increase in rainfalls in many areas. So you have an increase in diseases, in fungal diseases like powdery mildew, downy mildew, botrytis, etc. So with this increase, you need to do something. This is a catastrophic map that was published in 2013 by an American team, and it shows in red all the regions that will not be suitable for wine growing by 2050. It's a bit catastrophic because you see that many regions, I think, including Penedès, where we are, including Catalonia, including southern France, Bordeaux is out of the map, Piedmont is out of the map. Most of the famous wine regions are out of the map according to this catastrophic map. It has been moderated by other papers saying, wait a minute, we can still mitigate this increase in temperature by changing irrigation, changing leaf surfaces, and other viticultural adaptations. But what do we do with our Romanée Conti? Which grape variety do we cultivate there? Do we change the variety? Here we have a diagram I will show later with different varieties according to their suitability to different climates. So we could have late ripening varieties, but I'm not sure that they are ready to change that. We could have new crossings, new hybrids, question mark. I don't think that it will happen at Romanée-Conti or elsewhere. If we want to maintain Pinot Noir, which is the aim of most traditional wine regions, we could increase the agrochemical weaponry, including fungicides, including copper, the topic of this morning, including sulfur and many others. But this is not the road that any of us want to go. We could screen the clones of Pinot in order to identify which are the best for which terroir. And this is a good road. And one of the other interesting roads I will speak about later is the rootstock improvement. And also, I had to mention it, there would be a solution by genetically modified Pinot with a trademark or something like that. But at least in Europe, nobody wants that. So this is not a road that I will address today. So the grape diversity that is already existing is very, very important. If you want to replace a variety, you need to focus at such a diagram. So you have here different varieties, Müller-Thurgau, and at the bottom, Nebbiolo. And these are the average growing season's temperature. And these are the climate to which they are adapted. Like Müller-Thurgau and Pinot Gris is adapted to cool climate, Nebbiolo to warm and hot climate. And in green, since we are speaking about Pinot, I take it as an example. I could have taken Tempranillo or anything else. If we speak about Pinot, Beaune is in Burgundy. You see in dotted lines, this was the ideal, the best climatic window for Pinot between 71 and 99. It was right in the topic. Then, between 2000 and 2012, the ideal climate was here. Pinot is already out. And who will tell me that no good wine has been made in Burgundy since 2000? It's not true. We have found adaptations. But if we look at 2100, the provisions are here. So Pinot will be way out of the climatic window of Beaune, and maybe Nebbiolo would be best suited. Can you imagine one day seeing a label of Nebbiolo Romanée-Conti? I cannot. So another road is to use the hybrids. This is voluntarily a diagram that you cannot read. It's just an example from our book, Wine Grapes, to show how complex hybrids can be. This is prior, but you have Solaris, Regent, and all these new hybrids that have been created. And these ones are resistant to fungal diseases, but they have only one resistance gene. And they have been created by crossing a lot of different varieties, and at the top of it, you see different Vitis species. You have Vitis vinifera, which is the European grape, but other varieties from especially North America, Vitis riparia, labrusca, etc., etc. By combinations of all these, we were able to include resistant genes in the final product of these multiple crossings. But with one gene as resistance, it's not enough because the pathogens, the fungus, can adapt and overcome this resistance. So nowadays, researchers are creating polygenic resistant varieties. It means for a given disease, a given problem, you don't have only one gene, but you have 3 or 4 genes that are resistant to this variety. So if the pathogen can adapt to one gene, you still have another 2 or 3 to fight against this pathogen. So you increase the length of time with which you can cultivate this variety. It has been done by different crossings. In blue, for example, you have the resistance to Plasmopara, in green to Oidium. And you combine them all by different crossings. These are not GMOs. These are classical, conventional crossings with pollen, fertilizing pistil, classic. And you can obtain a variety with at least 3 resistance genes for the problem you have. This has been done in different countries. In Italy, these have been released, but they are not really resistant, so they don't have a name yet. In France, in 2018, it's very recent, 4 varieties have been released: Artaban, Floréal, Vidocq, and Voltis, and they have been accepted in IGP wines. In Czech Republic, France, Germany, Switzerland, research is going on with these varieties. But again, will we see one day Artaban Romanée-Conti? I don't believe in that. I took this book, very, very good book by Kim Anderson, which wine grape varieties are grown where. It's statistic books of the wine grapes cultivated all over the world. And I took all the surfaces, all the areas of hybrids and crossings. I made the addition and I made the percentage, and it only covers 4% of the world's surface. It's good, but it's not a revolution. And crossings and hybrids have been around since 150 years or 200 years. So in 2 centuries, we've not been able to revolutionize the traditional viticulture because most regions want to stick with their local indigenous traditional grape varieties. So my main message today is the use of the existing diversity is very, very important. Here you see 13 varieties. These are the 13 most planted varieties in the world. These 13 varieties cover 1/3 of the planet, of the vineyards on the planet. It's huge. You have Kyoho, which is a table grape from Japan, nothing to do with wine. But then you have Cabernet Sauvignon, only wine. Sultanina, maybe you know it. It's also called Thompson Seedless. It can be table grape or wine grape or resin grape, etc. You have Merlot, Tempranillo, etc. If we take 33 varieties, we cover half of the planet. And this is ridiculous because we have at least 1,500 different wine grape varieties that can be used for winemaking in the world. In the book that we have released, we had 1,368, and now we have 100 more. So almost 1,500, and we only cultivate 30 of them on half of the surface of the planet. It's not logical. These varieties, these local grape varieties, here you have the reconstructed temperature since Jesus Christ, let's say, and you have the warm medieval period and the Little Ice Age. Most of these ancient traditional varieties have already gone through these climate changes, and they have the plasticity and they have the genetic diversity that is suitable to cope with these climate changes. I made a map, I will not read all of it, but these are my stars of the future. These are grapes that I like very much. They are sometimes made by only one producer, and I believe in the future that they will increase. For example, Alfrocheiro from Portugal is a variety that is very fruity, low in alcohol. Same with Graciano. I believe in Graciano because it's also fruity, low alcohol, high acidic variety. I think it's the future. I could have mentioned also some varieties rescued by Torres Winery, but they are still not really on the market, like Moneu, Garo, etc. In each country, I have my favorite. I could name Niedera in Italy. I like this one, Sverdlovina Cerna, because it's the only variety with 5 consonants in a row in the name, as you can see. Chidriotico, etc. These are unknown varieties giving fantastic wines for the wine lovers, and I'm sure that in the future they will increase in importance. But for the traditional varieties like Pinot, like Nebbiolo, like Chasselas, Garnacha, we can use the existing diversity within the variety, the clonal diversity. We have more than 1,000 clones of Pinot that have been registered. We have more than 500 clones of Garnacha, Sangiovese, 113, Nebbiolo, etc. These varieties from the eastern part, we have much less clones because they have been less studied. But I'm sure that we can make the same work in this area and find a huge diversity. If we don't preserve this diversity now, it will be lost forever. So we can use genetics in order to improve the study of this diversity. This is a very recent, This is a very recent map, sorry for that. 98 Nebbiolo clones that have been sequenced, completely sequenced. This was impossible 10 years ago. 10 or 15 years ago, it would cost 20 million per clone, 20 million euros per clone in order to do that. Today it's $500. So the technique has improved, and we have here the first paper last year, 98 clones that have been completely sequenced, They have been compared, and they are completely localized in different areas in Valtellina, in Torino, Roero, Langhe, etc., etc. So we can observe the genetic diversity of the clones and use the diversity of the clones with this whole genome sequencing technique that has become cheaper. And finally, the rootstock selection is very, very important. It plays a key role in fighting against climate change. It has a major influence, but it depends on the vineyard condition. If you look at that, this is the Vitis vinifera part, so it's your Tempranillo, it's your Cabernet Sauvignon, your whatever. This is the rootstock. The rootstock has an influence on the bud break of the vinifera, on the tolerance to soil-borne disease, growth vigor, water use, efficiency, nutrient uptake, fruit yield, etc., many different parameters. And it greatly depends on the pH and on the soil condition, the chemical conditions of the soil. This is a complex diagram showing for Shiraz that the berry and the wine sensory profiles greatly depend on the rootstock. The rootstock are these black dots. Here you have different parameters like the tannins, like the color of the berry, the wine quality, the body, the acidity, etc., etc. You see that it's completely dispersed in this diagram, showing the influence of the rootstock on the same clone of Shiraz. And this is a summary of the results. Here is with own roots, ungrafted. You see the total of wine quality that is lower than any other wine made with rootstocks. We have only 3 rootstocks here. This is surprising because in my mind as a wine lover, I always thought that own roots vineyards give better wines. In this case, it was not the result. Well, it has been made in Australia by Australians. Maybe that's the reason. I don't know. I haven't tasted the wines. So this has been made in California only, and I was saying it depends on each terroir. This is a rootstock selection chart. It's fascinating. You start here and you look at what is your problem. If your problem is phylloxera, then you want the growth vigor effects. If you want very high, you go this way. If drought is a problem for you, you go another way. If root knot nematodes is a problem for you, you go another way. And at the end, you always have the answer of which rootstock is the most appropriate for your vineyard, for your problem. It's extremely complex. It took them dozens of years to identify, and this should be made in each and every wine region. It hasn't been done yet. There's still a lot of work to do. So my conclusion, we always hear that we must match the terroir with the grape variety or the grape variety with the terroir. It's not true. It's too simple. It's too naive to think that way. What you must do is to match the clone to the right clone, to the right rootstock, to the right terroir. And these 3 parameters create very complex conditions that have endless possibilities of studies. Then I think it's very important to understand the diversity among the varieties and within each variety, the clonal diversity in each variety and the diversity among the varieties in each wine region. And also, I will not address this topic, but I think it's interesting, the microbiome biodiversity is very important. Of course, if you increase the chemical treatments, you will kill the microbiome, so all the microbes in the soil, and then you will not have terroir, especially if you kill the mycorrhiza that are really, really important. You know that the grapevine itself does not intake much of the oligo-element of the soil by itself. It needs the transportation by arbuscular mycorrhiza to transfer the microelements to the plant. If you kill them, how can you speak about terroir? How can you speak about terroir? You could have soilless grapevines grown under a glass house. It would be the same. So this would be the topic of another conference. Thank you for your attention.